Okay, indices and roots. Indices are these things. It's an index, or a power, or an exponent. Roots are these things. And I could have, that's called a square root. I could have a cubed root or a fourth root. We'll get onto that and what they mean just in a second. But today, the eventual aim of today is to just work out this one, what rational and irrational numbers are, and work out how indices and roots are connected. And in the next two videos, we'll do evaluating roots and fractional powers. But that's another story for another time. Okay, how are indices and roots connected? So let's say I have 3 squared equals 9. The square root of 9 is 3. Let's say I have 4 squared equals 16. The square root of 16 is 4. Let's say I have 5 squared, which equals 25. The square root of 25 equals 5. So hopefully you can see where I'm going with this. Square roots are going backwards. A square root tries to find a number that you could square to get to the number inside the square root. So for example, let's say I have the number 4 inside a square root. So if we were to try and find a number, we should be thinking, what number, when I square it, what number when I square it equals 4? And whatever that number is, that's the square root of 4. So hopefully you can see that the only number squared to get 4 is 2. So the square root of 4 is 2. So if you have a square root, really that square root is asking the question, what number do I have to square to get to this number inside my square root? Alright, so I wonder if you can work out the square root of 64. Now sometimes, if it's kind of small, if it's under 100, and if it's a perfect square is 9 is a perfect square, 16 is a perfect square, 25 is a perfect square, because they're squares of whole numbers. So if you're lucky enough to get a square root of a perfect square, then you don't really have many options under 100. I mean, you can try them out. You can try out, let's see, what happens if I square 6? 6 squared. That's 36. Okay, that's too small. And we're trying to find 64, remember. The square root of 64. What happens if I have 7 squared? Well, that's 49. It's too small. What happens if I have 8 squared? That's 64. Okay, now we've found the square root of 64. If I go backwards, it's 8. So square roots are trying to go backwards. Okay, so that's what a square root is. There are also cubed roots. Let me do a similar thing over here. 2 cubed equals 8. The cubed root of 8 is 2. So the cubed root of 8 is trying to find the number that I would cube to get 8. And that's 2. I'll write this one first. Cubed root of 27 equals. What number, if you times it by itself 3 times, if you cube it, would get to 27? And that number is 3. Okay, there's also fourth roots. or fifth, I don't know why I wrote a 4 in there. Could write anything I like in there. Fourth roots or fifth roots. And you might be thinking, some of these roots are not, I don't think I'm going to be able to work them out. For example, let's say if you had a square root of 5. Now, you could try and work this out. You could say, well, let's just try some numbers. 1 squared is 1. 2, that's too small. 2 squared is 4. 3 squared is 9. But now, hopefully you've realized there's a problem here because 5 is in between 4 and 9. That means the number I'm squaring, or the square root of 5, has to be somewhere in between 2 and 3, but we don't know exactly where it is. And this introduces the next topic, which is irrational numbers. The square root of 5 is a particular type of number, which is very hard to get without a calculator. And even if you use a calculator, you can't find it exactly. All right, and by the way, when the calculator is trying to find a square root, the calculator does this same sort of trial and error thing that we are just doing. Tries one number. If it's too small, it tries a bigger number. And if that's too big, it tries a smaller number. Anyway. All right, so a really quick history of numbers. Natural numbers are just positive numbers that are not 0. So 5 and 8 and 156, they're all natural numbers. So they're the numbers that we just use for counting. They come naturally to us. Now, negative numbers were only invented when certain problems came around. Like, for example, let's say Fred is broke and Fred owes Alicia $25. And we have to ask the question, how much money does Frank really have? Well, he has $0, but at the same time he owes Alicia $25. So that kind of means he has negative $25. And so we had this idea of negative numbers. And so we needed a new set of numbers or group of numbers, and that was called integers. So natural numbers are also integers. So integers includes 0, -2, -25, and also 5 and 8. Then you've got this thing called rational numbers, which includes decimals. I've written here finite decimals. So decimals that just stop like that. Recurring decimals, where they've got a repeating pattern, like 3, 4 happens again and again and again. And fractions also. So all of these are types of rational numbers. And finally, you've got irrational numbers, which don't fit into any of these categories. If you have the square root of 5, that's not going to be any of these, and I'll show you why that is. Where's my calculator? Here it is. The square root of 5 is 2.236067977. So this isn't repeating. It's not finite. It looks like it stops there, but actually the calculator's just rounding it off. It actually goes on forever. So that's an irrational number. Now, not all square roots are irrational. If I have the square root of 9, remember that's the number that I have to square to get 9, which is 3. The square root of 9 is not an irrational number. But the square root of 5 is an irrational number because it's not a perfect square root. And by the way, the square root of 5 is also called a surd. That's the irrational number, square roots. Okay, let's do a quick test to see if we understood. I might do another couple of questions even before number 1. Why don't we call them question -1 and question 0. So this one, what is the square root of 16? So have a think about it. It's a number that I have to square to get to 16. And that would be, if you do some tests in your head, you'll find out that it's 4. Okay, what about the cubed root of 8? The number I have to cube or times by itself 3 times to get to 8. So that can't be 1, because 1 times 1 times 1 is 1. It can't be 3, because that's 3 times 3, 9, times 3 again is 27. So it's in between 1 and 3, it's got to be 2. 2 times 2 times 2 is 8. Alright, question number 0. What was I going to do for this one? I can't remember. Alright, let's get to the normal questions. Which of these are rational, which are irrational? So the first one, it's a finite decimal. It stops here. So that makes it a rational number. Think about the rational numbers as being easier to understand. A little bit simpler. This one is just going on forever. I should have done a ... But it just goes on forever, but there's no pattern at all here, is there? So this is an irrational number. Doesn't make sense, hard to understand, however you like to think about. That's what irrational means. This one has a repeating section, so this is actually a rational number. This one ends up being 3, so it is a rational. And this one, it's not a perfect square in here, so it's an irrational number. And again, if you put it in your calculator, it'll go on forever. Okay, there we go. So in this video, just to recap, we covered what are indices and roots, and we covered rational and irrational numbers. See you in the next one, evaluating roots.